laws. So we're just going to look over what index notation is. Index notation is the use of powers to write repeated multiplication of a number. For example, 5 to the power of 3 equals 5 times 5 times 5. When you see the number 5 to the power of 3, the 5 is called the base and the 3 is called the index or the power, or it's also called the exponent. So the base number is on the bottom and the other one is called the index or the power or the exponent. Now, when multiplying, we're looking at the index laws now. Terms with powers that have the same base. We're looking at 4 index laws. Now, there are 4 index laws. The first one is a to the power of m times a to the power of n is a to the m plus n. Might be double Dutch for you. What I'm going to do, I'm going to give you an example. X squared times x cubed. X squared, isn't that x times x? And isn't x cubed x times x times x? Yes or no? So how many times have I multiplied x by itself, basically? Don't I've got 1, 2, that's the x squared, and the x cubed is x. What does that equal? X to the power of? How many more times have I multiplied x by itself? 5. So, do you notice that all we've done is add the 2 and the 3? Okay, that's the first index law. Now, the second index law is a to the power of m divided by a to the power of n is a to the power of m minus n. I'm going to give you show you why this is the case. X to the power of 5 divided by x squared. That's an example. Isn't x to the power of 5 x multiplied by itself 5 times? And x squared is x multiplied by itself twice. Now, you know how I said if you've got multiplication symbols you can cancel? 2 x's cancel with 2 x's. And you're left with x to the power of 3. So it's just easier to say 5 minus 2 is 3. So when you're dividing terms, but the bases have to be the same, you just subtract the indices, the indexes. So they're the first 2 index laws. The next index law is raising a power to another power. I'll give you an example. This time I'm going to use a. A cubed squared. When you square something, isn't it really something times itself? Yes or no? Actually, you know what? I might do it to the power of 4, make it a bit more obvious. A3 to the power of 4. If it's to the power of 4, don't I do A3 times itself a total of 4 times? Yes or no? Now, if we go back to rule number 1, if the bases are the same, what do I do with all these 3's? What do I do with all the 3's? Add them. That's a to the 12. Notice, wouldn't it have been easier to just say 3 times 4 is 12? And that's our third rule. When you've got a, m to the power of n, a power to another power, all you do is multiply the powers. I've just shown it to you with an example. It's the same as a to the m times n. So here is an example showing that to you. I've gone back to basics and showed you how it works. Now, girls, with the last one, any number raised to the power of 0 is 1. You can go to your calculator and do 5 to the power of 0, negative 5 in brackets to the power of 0, 120 million to the power of 0, anything you want to the power of 0 is 1. I'm going to show you why. I'm going to show you why it works. So, just watch what I'm going to do here. What's x squared over x squared, ladies? No. What's anything divided by itself? All right, good. Now, I'm going to do x squared over x squared another way. X squared over x squared is the same as x squared divided by x squared. Do you agree? And if the bases are the same, can't I just subtract the indices when dividing? 2 minus 2 is 0. Now, I've done the same question two different ways. X squared over x squared is 1, and x squared over x squared is x to the 0. That means that x to the 0 is 1. Okay? I've just done the same question two different ways, proving to you that x to the power of 0 is 1. y4 times y6, that's y times y times y times y, and another 6 of them. Or, what's the rule? No. Y times y times y times y times, you add them. In this rule, it's what we're doing is adding. Do you get it? We're adding the indices. Right, the next one, we multiply the numbers. What's 8 times 3? So with the next one, we do 8 times 3. This is how we do it in our head. 8 times 3 on its own is 24. X squared times x5 on its own, what would you get? Because you've got to do it in two parts. Let's deal with the numbers first, and let's deal with the x's. What's x squared times x to the power of 5? Just think what it means. X times x times x times, yes, I got the idea. It's x to the power of 7. You're adding the 2 and the 5. Do we get it? The next one, when you're dividing, it's much easier not to use the index laws and do it as a cancellation. So b to the power of 10 divided by b. What do we end up with, everyone? We do end up with b to the power of 9, but if you were to use the index laws, it's b to the 10 minus, isn't this power a 1? So if you were to use the index laws, you would get the same, or you can do it by division. The next question, do the numbers first. So 24 divided by 4 is, what have we got? 6. And R6 over R2, what's that equal to? What does that equal? R4 on the top. All right? That's R4. And your 24 over 4 was 6. You can sort of do it in 2 bits. The next one, be very careful. I need everyone checking their answers. It's 5 is squared as well. Did you get 25? Not 10. It's 5 squared and then A3 squared. They're both squared. 5 squared is 25. What's A3 squared? A to the 3 times 2 is 6. The next one, be very careful. You know what I would do if I were you with all these bracket ones to the powers? It's 1 cubed over 2 cubed times p cubed. Do you see that everything in there has been cubed? 1 is cubed, 2 is cubed, p is cubed. How are you with that? And I think if you do it that way, you're less likely to make a mistake and everything stays in its proper position. Just like this, 5 is squared and 8 cubed is squared. So we've got 1 over 8p cubed. The next one, let's use that method. 6 is squared, m3 is to the power of 2, n5 is to the power of 2. See how everything is to the power of 2? What do we get? 36, m to the 6, n to the 10. To do the same thing here as well. I'm going to make everything to the power of 5. Girls, a negative times a negative 5 times is it's a negative. Every odd, if it's an odd number of times, it's a negative. Then we've got d squared to the power of 5. E is to the power of 5. F cubed is to the power of 5. Ladies, a negative to the power of 5 is a negative. Negative times negative, watching. 1, 2, 3, 4, 5. It's only when you've got even powers of negatives that you end up with an even, with a positive. Look, a negative times a negative times a negative times a negative times a negative ends up on a negative. D squared to the power of 5 is d to the power of 10 over e to the power of 5. F3 is to the power of 5. That's f to the power of 15. 2 times 3, looking at the numbers first, is 6, and x times x is x cubed. Now with the next one, Notice the power is not on the outside of the bracket. So we've got a negative times a negative is a positive. Because look, negative times a negative is a positive. Now, so the negatives, the signs are taken care of. With the numbers, that 8 is not to the power of 5. So it's just an 8. And then we've got w to the power of 6 times w to the power of 5. That is w to the power of 11. All right, with the next one, it's best to write these as division problems. So 10m to the power of 9 divided by 5m to the power of 3. 10 divided by 5 is 2. And m to the power of 9 over m to the power of 3 is m to the power of 6. You can do it by subtracting the indices if you want, or you can also imagine that you are cancelling out. Okay, now for question D. Looking at your numbers first, 6 over 20, you can put that into your calculator, or you can just divide them both by 2 and you get 3 over 10. So that's just looking at the numbers. And then looking at the C, so we had 6 over 20, is 3 over 10. Now let's look at the C10 over the C. So I'm just going to look at the numbers and then the C's and then the D's. C10 over C is the same as C10 over C1, which is C to the power of 9. So that will be on the numerator because there are more C's on the numerator than the denominator. And the D3's actually cancel out and you're left with nothing there. So D3 over D3, they cancel out to give you 1. Okay, so the answer is 3c to the power of 9 over 10. I'll just get rid of that there. Now this next one, everything is to the power of 5. So 3 is to the power of 5. And the a to the power of 4 is also to the power of 5. So 3 to the power of 5, you just need to do that on your calculator. I think that's 243. And then the 4 times 5 gets multiplied here, and 4 times 5 is 20. So the reason we multiply these is we've got a power to a power. Now the next one, a negative to the power of 7. 1, 2, 3, 4, 5, 6, 7 leaves me a negative. Then we've got 3 to the power of 7 and p squared to the power of 7. And then q is to the power of 7 and then r is to the power of 7. I'm just going to rub this off here. So I've got, now I just have to work out what 3 to the power of 7 is. Now 3 to the power of 7 is 2187, so I've got negative 2187, p to the power of, now, a power of a power, 2 times 7 is 14, then I've got q to the power of 7, r to the power of 7. Now with this next one, before I cancel, I'm not allowed to cancel yet until I expand this bracket down here. So I've got 18r8w5 over, now this is 2 to the power of 2, and then r squared to the power of 2 and w to the power of 2. So I'm just going to simplify that first before I cancel. 2 to the power of 2 is 4. R squared to the power of 2, that's a power of a power. And 2 times 2 is 4. And then I've got w to the power of 2. Now 18 over 4, that simplifies to 9 over 2. R8 over R4 is R4 on the numerator there. And w to the power of 5 divided by w squared is w to the power of 3 on the numerator. I'll just move that 2 in the middle over there. So it's 9r to the power of 4, w to the power of 3 over 2. Now, question 3, which of the following is the simplified version of this statement here? So we've got 14k times 5r over 5r times, now this is 10r squared, I think. 10r squared is on the numerator, so you put it over 1. So we can multiply through, or we can do some cancelling out. I'll just multiply and I get 140k r squared over 5r. Now on your calculator, just 140 divided by 5 is 28. So that gives me a 28. The k stays there. And one of these r's cancel with an r on the denominator, so it's 28kr, which is D. Okay? And now for question 4. Now, I've got to be careful with these. These two expressions here is different. Now, we know that anything to the power of 0 is 1. But here, this first one means 2 times m to the 0 minus 2m all to the power of 0. So, 2 times, now this m to the 0 is 1. So it's 2 times 1, take away. Now all of this is to the power of 0. And anything to the power of 0 is 1. So that's 2 times 1. So that bit there equals 1. So 2 times 1 is 2, minus 1 is 1. With the next one, all that 5y's to the power of 0, which is 1, take away 4 to the power of 0 is also 1, so 1 take away 1 is 0. This next one here, a half to the power of 0 is 1, plus a half y to the power of 0 is 1. Because they're in brackets and it's all to the power of 0, it's 1. So 1 plus 1 is 2. This one here, again, got to be careful. This is 8 times b to the power of 0 minus, now this is 3b to the power of 0 squared. Now 3 squared is 9, and b to the power of 0, actually before I do that, I'm just going to work out what 3b to the 0 is. That's 3 times 1, so that's minus 3 squared. That's probably the easiest way to do it. Because 3b to the power of 0 is 3 times 1, which is just 3. So it becomes minus 3 squared. Now 8 times b to the power of 0 is 8 times 1, which is 8, minus 3 squared is 9. So 8 minus 9 is negative 1. It's a tricky one, that one. And now for the last one. This is cubed, so it's 3 cubed times x3 cubed divided by, so I'm going to put it over x to the power of 9. Now 3 cubed is 27. x3 cubed, power of a power, you multiply the powers. 3 times 3 is 9. So you get 27 x to the 9 over x to the 9. Now we can cancel. This is 27 times x to the 9 over x to the 9. They cancel to give me 1s, which is just 27. If you want to use index laws, I could have done it as 27 x to the 9 minus 9 is x to the 0, and that would have been 27 times 0, which is 27 as well. But I think when dividing, it's much easier to put them over each other. I'm just going to get rid of that there as well. Right, and that's the end of the examples. So now you can do exercise 2.03.